Okay, good morning. Thanks for signing up and attending today's webinar. My name is David Simpson. You can see, hopefully, my information on the bottom of your screen. My email address, dsimpson@themisinc.com. Great way to get in touch with me. If you have questions or thoughts about anything that we talk about today, don't mind answering those questions or having a conversation with you guys as we go forward. That's kind of the way I stay in touch with what's really going on out there in the world of DB2. So I don't mind that at all. You can also follow us at Themis Training on Twitter. We are just not too long ago launched our Twitter presence. So as a simple way to say thank you for this webinar, if you're on Twitter, go give us a follow there. That would be awesome, and that'll also be an easy way for you to see what's coming up in future on webinars and classes and stuff. A lot of people already asking about how to get the slides for this presentation. So if you go to our website, www.themisinc.com, the slides are available there. So you've got a link right here, www.themisinc.com/webinars. There you will be able to see replays of past webinars. We got quite a few of them out there from about the past year and a half or so. We've been doing these. They're recorded as or put up as YouTube videos, so you can watch. Also, the slides for this and all of the past webinars are out there as well. So if you would like the slides from today's webinar, www.themisinc.com/webinars. The link is right there on the screen. And toward the top of that page, you'll see an entry for today's webinars. It's actually under the past webinars. You'll also see we have a couple of them already scheduled. If you're an Oracle person or if you know Oracle people, we have with John Mullins tomorrow, one of our Oracle specialists, Oracle SQL and PL SQL tuning tips. That's coming up for tomorrow. And the link to sign up is out there at the website. And also, I'm going to do a part 3 of this presentation in April, on April 27th. If you'd like to come back for that, you can sign up there as well. Also, the part 1 of this webinar was back in February. So fairly close to the top of that page is the replay of that if you would like to start from the beginning. So I think this will be a 3-part series, SQL for the 21st century, focused on DB2 SQL. The part 1 we did in February. Again, the replay is out there. Part 2 is today, and part 3 will be April 27th. You can sign up all at that same place. So again, for those of you just joining, if you want the slides from today, go to that website, www.themisinc.com/webinars. And there's a PDF link under the heading of today's webinar where you can grab the slides. Also, the replay from this one will be out there as well, hopefully later today, might be tomorrow, for any of you who have friends or know people who were not able to attend today. We'll have the replay up there in the next day or so. All right, so the webinars are a great way to get a little bit of free education, but the material we're going to talk about today actually comes from a class. This is what I do now, right? I work for this company called Themis Education. We do pretty comprehensive training across a lot of IT disciplines. One of our big strengths is databases, and DB2 in particular. I do a lot of these classes, both SQL, application programming, DB2, DBA stuff. We do that in a public scenario or public venue with both the virtual training and at sites around the country. And we can also come to you if you have a big enough group to put together. So again, you can feel free to reach out to me via email. My email address was on the first screen, and it'll also be we'll put it up there again at the end. Okay, so that is the word from our sponsor. This is a little bit about me. You can read about that in the handouts if you'd like. I've been doing this DB2 thing since about 1993 in a bunch of different capacities. For about the last 9 years, I've been working for Themis doing this training consulting thing, which is a real blast. So the stuff from today's webinar is part of our Advanced SQL for DB2 class. And again, if you pull down the PDF of this, there's links in there to the description of that, and you can see our public schedule there as well. So the last webinar we talked about, and this was, the topic here is SQL for the 21st century. In the February one that you can see the replay for if you'd like, we talked about actually some features that came into DB2 quite a while ago, about 10 years ago in version 8. We talked about table expressions and a little bit of recursive SQL and such. So I picked out a few new features, sort of new features for this one. We're going to look at one from version 9, one from version 10, and one from version 11, and they all kind of go together and build on each other. So we're going to look at some enhancements to the built-in functions, and then later in the webinar with aggregation and grouping. So again, if you'd like the slides, themisinc.com/webinars. You can pull them down and follow along if you'd like. So we'll start off with a little bit about built-in functions for ranking and numbering. IBM calls these the OLAP functions. In their documentation, OLAP, OLAP, Online Analytical Processing. There's really 3 of them, and they work very similarly, and they were for ranking and numbering things. So the stuff we talk about in version 10 is going to build on this kind of functionality. So let's take a look at that rank function first. This was a new built-in function in version 9 of DB2, and it just allowed you to rank things. Right, so the rank function itself there, all of that stuff on the second line of the query is one column in the final result set that we're calling R. So you see it on the right, on the bottom right there. We want to select the person's last name and salary and then rank. The rank function itself doesn't take in any arguments, but it expects this over clause that is going to determine how we're going to do the ranking. So in our case, you throw in, you can actually have one of 2 things or both things in there. You can have a windowing clause or a partitioning clause. And what you're seeing right there is an order by, right? An order by is going to define how these things are going to be ranked. Keep in mind that we have to distinguish that from the order by that is the entire result set. And we'll see an example of that in a minute. I'm saying in the rank functions in the over clause, order by salary descending, that's going to control how the numbers are, or how the people are ranked out of my little fake employee table here. This and all the examples we're going to see are using the good old IBM sample, or kind of a sort of modified copy of the IBM sample database. So all of you have these tables in some fashion or another on your systems. If DB2 has been properly installed, right? So the rank function, order by salary descending, and you can see on the right, on the bottom right, that we've gotten a rank assigned based on the person's salary. We have a tie at number 1. So Haas and Moon both make the same salary, which is the highest, and you see the rank function assigns them both the number 1. Lucchesi's down there at number 3, and we skipped the number 2 because we had a tie at number 1. So that's how the rank function works. All right, so if I had 3 people at number 1, then the next number assigned would have been 4. Okay, so this is kind of typical ranking of things. Right, Pulaski down there toward the bottom makes the 7th highest salary, and he is in fact actually the 7th person on the list. Okay, so the order by in the over clause here is determining how the ranking is going to be done. And then in my final order by, I said, please let's order the final result in that same way. So put the highest salaries at the top and the lower ones at the bottom. And again, the differentiation here is the first order by is determines how things are going to be ranked, and the final order by determines how we're going to see them. And you can see in this example, we shifted just a little bit in the final order by there. When I make them different, you see what's going on, right? The over clause says we're still ordering by salary descending. So good old Christine Haas there, she's still number 1, but we did the final result ordered by last name. So Adamson's at the top. At $25,280, he was the 19th highest salary, but we put him at the top because the final order by says last name. So you see one order by controlling the ranking and another one controlling how we see them. Okay. We can add to this. We can have both a partitioning clause and an order by clause in this over. So here we're doing both, and I'm saying please partition by the department number and order by salary descending within that. Now, for those of you who are DBAs, DB2 has this whole partitioning mechanism for actually breaking up physical table spaces. You got to forget everything you know about that. So this is an SQL kind of partitioning, not a physical, database kind of partitioning. When I say partition by DEPTNO, I'm saying we're going to group the rows or the results by the department number, and then within that, I'm going to order by salary descending. So on the right here, you see that Haas and Moon, they are still in the same department, and they were both still tied at number 1. Lucchesi and O'Connell are 3 and 4 within that department A00. But then when I get to a new value for department number, I start over. So there's only one guy in B01. There were 3 people in C01, and they're ordered 1, 2, 3. So this is kind of like a control break, right? I'm providing a control break with the partitioning. So partition by DEPTNO, but then within that, order by salary descending. And you can have both of these clauses in the over that modifies the rank function. Okay, again, this is relatively new, came in version 9 of DB2. And I've been being asked since, early on in my days as a DB2 person, how do I assign numbers to things, right? How do I number my rows? And the rank function is one way to do that now, built in with SQL. There are 2 more functions that work very similarly here. One of them is dense rank. Dense rank, you see, is the syntax is exactly the same as rank. Just the only thing that changed here was the function name. And you can also see probably pretty quickly what changed. Haas and Moon are still tied at number 1 here. Lucchesi is assigned the number 2 by the dense rank function, where it would have been number 3 by the rank function. So the only difference here is how we deal with ties, right? We still respect the tie, we just don't skip any numbers. So you don't have any gaps in your numbering here. A little bit odd that Pulaski, going to show up as number 6 when really Pulaski is the 7th highest salary, or the 7th highest earner in our little fake company. But the dense rank is not going to give you any gaps in the numbering. The third OLAP, or online analytical processing function, that came in version 9 deals with row numbering. This is, again, works exactly like rank and dense rank. The only differences here deal with ties, right? So where rank assigned the first 2 people in our table numbers 1 and 2, or I'm sorry, numbers 1, both of them, and then skip number 2. Dense rank assigned them both number 1 and didn't skip number 2. Row number just numbers the rows, right? So Haas and Moon, even though they're tied, they get the numbers 1 and 2. We're just going to pick one to be first. Okay, it's not going to be real predictable which one that is. So the 3 functions work very similarly. The only differences between the 3 are how they deal with the ties. Do we skip numbers? Do we not skip numbers? Do we duplicate numbers for those ties? Okay. Other than that, I can use any of those same partitioning or order by clauses in that over of any of the three functions. They're all going to work the same that way. Okay. I can put a more complex order by in there. So you see here I've done a row number where my over includes an order by salary descending and bonus descending. Okay, so now I don't have any ties, right? The person's salary who's tied, you're gonna go look to the bonus to break the tie. So whether I used rank, row number, or dense rank here, Haas and Moon would get the numbers 1 or 2, 1 and 2. Okay. So you can have a more complex order by in the in that over clause that will help take care of those those ties. All right, so that's the version 9 stuff I wanted to talk about. Those three functions: rank, dense rank, and row number. You'll hear people talk about them as the OLAP functions, online analytical processing. You'll see them described in the documentation that way. It's really just those three functions. And some people have found those to be real useful, without having to do this in external code. You just have them as built-in functions. These are scalar functions, meaning they only, they don't change the number of rows that come out of your result. We're just numbering them. But they're a little bit special in the sense that scalar functions can usually be used just about anywhere, meaning either in the select or in the where clause. These three functions can only be used in the select list. So I've had some people try and use these to develop top 10 kind of things, where the rank is less than or equal to 10. But you can't put them directly in a where clause. Now you could throw it in a table expression in the select and then use that table expression to develop a where clause. But you want to be a little bit careful about that for performance, that you're not over materializing. All right, version 10, here's a version 10 feature, moving aggregates. This has to do with applying the same stuff in that over clause that we just saw in the OLAP functions to our traditional column functions. So the normal column, or what I used to sometimes call aggregate functions, average, sum, min, max, these are the ones that we're probably going to be using with these moving aggregates. This allows you to do kind of a running total or a running average or something like that. And so we're going to combine what we just saw with that order by in the over clause with these column functions, okay, or sum, average, min, and max. So here's an example of that. So here you see the sum function. Right, the sum function is a column function or an aggregate function, and usually the sum function wants us to return, or wants to return us, only one row. By the way, I mentioned this a minute ago, I think, but these are version 10 new function mode features that you're looking at right here. Sum of salaries. So normally, if I threw the sum function into a select list here, and I don't have a group by, then I wouldn't be allowed to select anything else, right? So the sum function wants to return you one row without any other modifications like a group by or now this over clause. So you can see what I'm doing here. I'm going to say I want to grab some detailed data along with the sum, and I want to order by, I want to do this over a set that orders by salary ascending, rows unbounded preceding. Okay, we'll have to talk about what that syntax means in just a second. Let's actually see what it does in the result set first. So that last column in this result set is the result of that weird sum function. And what you can see here is that the sums are ever increasing, right? The value in that last column is always increasing. So it starts out with a salary of $15,340 is the first person. This is their detailed salary in the third column, right? In the fourth column, for the first row, you see just 15,340. Well, the second person makes 15,9, and in the final column, you see that we've added the two numbers together, right? 15,340 and 15,9. What you see here is kind of a running total, right? A running total of the salaries of all of these people, going from the first guy all the way down to the bottom. So let's actually take a look at that problem again and talk a little bit about what this means. So here I'm saying I want to sum the salaries. I'm going to order by salary ascending, start from the lowest salaries and move up. Rows unbounded preceding. That means we're going to go all the way back to the first row that was in my set. Okay, so the first row that was in the set. Rows unbounded preceding. Okay, we're going to see some examples of where I can modify that a little bit in a moment. But that right there, I'm saying you're defining how far back we go, unbounded preceding, all the way back to the beginning. A second example now we can use with the partitioning clause. So here I'm saying I want to partition by the department number and then order by the salary ascending. So remember what that partitioning did back in the ranking examples we did earlier. It's kind of like a control break. Right, partition by the department number, and then within the departments, order by salary ascending. Notice too also that the order by at the final order by at the end of this query, I've kind of matched up with my order bys or my information in that partitioning. In other words, I'm going to be grouping by department number first, and then within that ordering by salary, I would kind of like to see the final result in that same sequence. Right? Department number, then salary. Salary ascending in this case. And we can see what that does now. So the first four people work in department A00. Right? We're getting a running total of all of their salaries, and then the partitioning clause kicks in. And for B01, we start over. And C01, we start over again. And you see that running total goes until we hit a new department, and when we get a break, it starts over. So by combining that partition by clause and the order by in the over, I've developed a control break process that's keeping a running total of my payroll for these people. Again, you can put any kind of order by clause in there you want. It can be a very simple one like the one we've got, or it could be more complex. You could have more columns involved in that order by. You want to probably make your final order by, consistent with the what's in your over clause, so that you get a result that makes sense. Okay. All right, so in this example, the third example here, we're still doing partition by department number. We're still doing order by salary ascending. Let's start on the left side here first. Instead of doing rows unbounded preceding here, I'm saying I want rows to preceding. What that means is that I'm going to get an average in this case that is only taking into account the current row with the two preceding rows. Okay. Now let's talk about what's on the right side here. On the right side, you have the same thing really, where I'm casting the final result as a decimal 9,2. Well, let's talk about that for just a second. This is why I have a brief interlude here. This is not a version 9 or 10 thing. This is a rounding thing for DB2. So the first example that I have here, I'm casting the number 3.77 as a decimal 9,2, 3.777. And when you do that, DB2 gives you a number shortened to decimal 9,2 format But DB2, when it shortens a decimal number, does numeric truncation. It does not do rounding. If you're familiar with Oracle or SQL Server or most other database platforms out there, they will almost always round this number for you. But DB2 has always done numeric truncation. Okay, so if you take the number 3.7777 and round it off, or I'm sorry, and cast it as a shorter, decimal 9,2, it will not round it off. You just get 3.77. Well, fortunately, there's a round function, right? And the round function will actually take that number and round it off at a, as a more precise decimal. However, round function does not change the data type. So if you had 5 digits of precision like I had here, and you say round it to 2, it does round it to 2, but it doesn't shorten it. So you get, 3.78000. The third one there, I'm showing you at least one way you can screw this up if you're trying to both round and shorten it. Here I'm casting it as decimal 9,2, and then rounding it as at 2 decimal places, which is the wrong order, right? I got to round first and then cast, and that's what I'm doing on the very last example. So I'm taking my number, right? These functions work inside to out. If you look at the very inside there, I'm taking the number 3.777, which could be any column or expression, rounding it off at 2, and then casting it as a shorter number, okay? And that is exactly what this example is doing on the right side here. We're simply taking that round function, or that's average salary function, rounding it off at 2 decimals and then casting it as decimal 9,2. Right. So that's just to get us a rounded, shortened number, rather than what the average function will return you, which is a lot of precision. Okay. We can look at some of these other, things we can do in these moving ranges. So you see this example, I'm doing rows between one preceding and one following, rows between 2 preceding and current row, rows between 2 preceding and 1 preceding. You're just defining your window here, right? So in my case, I was doing a running average in this previous example, and this is just saying which rows are going to be averaged with the current one. Right? Up until now, we had been saying rows unbounded preceding, meaning all of the ones going back to the beginning of my window, but you can actually limit that window, even make it more precise. I'm trying to think of good examples of why you would do anything but unbounded preceding, and I can't think of great business examples where this makes sense, but perhaps you can find some. You got a lot of flexibility built in here. We can also use range preceding, right? So the range thing, so when we did rows unbounded preceding or rows between 2 preceding and current row, I'm saying go back 2 rows to to figure out what to average or sum in my list. Range between is dealing with actual ranges of values in the number that you're summing or averaging. Okay, so this you would only use for numerics. Well, really, a lot of these you would probably only use for numerics. So in this example here, I'm now saying I'm still summing salaries. I'm ordering by salary ascending, range between 10,000 and 10,000 preceding and current row. So let's see how that works out. So you see my list of people here, and we're starting with the smallest salaries. So every salary to be considered is going to look back, in this case, $10,000. If I'd said rows preceding, it would have been 10,000 rows, right? But when I say 10,000 with a range, I'm talking about actual range of values. So if you actually do the math on this one, that row, that first employee number 190, third from the bottom, if you were to actually sum up the salaries preceding, only the red ones would be counted because those are the ones that are within 10,000 of, I'm sorry, 5,000 of his salary. Did I say 10,000? Yeah, I'm sorry, if you're looking at the handout at home, and I'll fix this on the website, this was actually, when I ran it for real, 5,000 instead of 10,000. I apologize for that. So we're looking at within 5,000 of this actual range, and these are the only ones that that would be counted. Okay, again, can't think of great examples why you'd want to do this, but you have really tight control over that window that can be used there to define your sum. All right, so that was the version 10 stuff. Now we'll take a look at version 11. One feature on version 11, I call this one advanced grouping. Those of you who do DB2 LUW, this is actually not new in version 11. The other two features that we talked about were, the OLAP functions came in version 9. The moving sums and aggregates came in version 10 on both of these platforms. The advanced grouping stuff actually came to DB2 LUW quite a while ago. I'm thinking maybe version 8. For those of us who do DB2 on ZOS, this is new. And we just got it in version 11. Okay, so this is extensions to the group by clause that will allow us to do things that we couldn't do before. So in this example, I'm doing a select department number, job, and average salary, right? Barring some of that stuff we just talked about, if I'd select DEPTNO and job along with an average, I have to have a group by. And in this case, I would have, in a more traditional group by, I would have had to group by department number and job. The change with the grouping sets, or what I'll call, I guess, advanced grouping, is that I can now group by more than one thing at a time. So in this case, I'm saying group by grouping sets, and then I don't want to just group by DEPTNO and job. I want to group by DEPTNO and job, but also DEPTNO just by itself. So both DEPTNO and job and DEPTNO by itself. And that will allow you to develop a result set that looks something like this, where I have rows that came from the first group by. So these first 3 rows came from the grouping of DEPTNO and job. And then the final 3 rows came from, or the 2 rows highlighted in yellow actually came from this other group by, DEPTNO just by itself. Okay, so this is allowing me to group by both of those things at the same time. What do you suppose this value is, right, for A00 that didn't have a job? That value is actually going to come back as a null. Okay, so that null value there is something that's going to be generated by one of these grouping sets that just doesn't include the column that we're looking at. Okay. In this example, I added one extra thing to the grouping sets, and that is just an empty set. And now I get an additional row down at the very bottom that is as if I had grouped by nothing, meaning the average salary for everybody that meets the conditions of my where clause. Okay, so the grouping sets thing is a new thing in version 11. Again, it's been on other platforms for a long time. It's been on DB2 LUW for a long time. I say it's new in version 11 for DB2 ZOS people. In addition to that, we have some common sets of grouping sets that they have given us shorthand for. So here I'm saying group by a roll-up of department number and job, and I get the same answer as I got in the previous example. The roll-up is simply shorthand for this, which is group by grouping sets, department number and job, department number by itself, and an empty set. So that's just shorthand for those particular grouping sets. If I add a third column to the roll-up, then you can see what I'm doing. I'm just taking one column off the end of the group by until I get down to nothing. So department number and job and ed level, department number and job, then department number by itself, and then the whole thing. They've also given us another shorthand, which is cube. And cube is doing all of the permutations. Okay, so here I've said group by cube of department number and job, and the equivalent grouping sets on the next slide. Department number and job, department number by itself, job by itself, and the whole thing. The one with job all by itself is the one that I get from cube that I did not get from rollup. Right, so since job wasn't the high order thing, I never got it by itself. Cube just gives you all the permutations. Okay, so if I add a third column to the list, now I'm getting DEPTNO job and ed level. The cube of that is DEPTNO job and ed level, DEPTNO and job, DEPTNO and ed level, job and ed level, each of the three by themselves and the whole thing. Okay, so in a query like this, I've had it happen where the actual summary that I'm generating here actually generated more rows than the detailed data that I was summarizing, because I'm summarizing it so many different ways, all in the same query. Okay, so the grouping sets, rollup and cube were three things that came into DB2 for ZOS version 11 that did not exist there before. Again, these existed in other platforms, particularly DB2 LUW has had these for quite a while. And we're starting to see the chart of things that the two different flavors of DB2 support becoming almost the same. So every release, IBM puts out this big Venn diagram, right, of here's what you can do on LUW with SQL, here's what you can do on ZOS, and here's what, the stuff that's the outliers on either side. This one was one of those outliers on the ZOS side, or the LUW side, I guess, that you could do on LUW but not Z. It was there for years, and they finally addressed it in version 11. Okay. So that is what I wanted to talk to you about today. As I mentioned earlier, the webinars, themisinc.com/webinars is where you can get the slides from today. Also see the replays from the past webinars. Please follow us on Twitter at Themis Training. I will put my email address back up. That was actually on the first slide. Sorry, I thought I'd put it at the end too. dsimpson@themisinc.com. So feel free to reach out to me if you have any additional questions or anything you'd like to talk about. Again, I don't mind that. That's one of the ways I keep in touch with what's going on out there. So thanks for attending today, and look forward to seeing a lot of you in classes and webinars in the future. Thanks.